So I hope you're all having a good start to your week already. This is one of my favorite conferences of the year because I have a lot of great conversations here throughout the week with a lot of the attendees. I'd like to learn a lot about what you're all doing, and I hope you all like to talk to all of us, the speakers, because we'd love to hear from you all. So today's keynote is about a story that I've lived for the last several years, and there's a lot of code out there that we write. Developers write a lot of code, and we have to learn how to take that code and then push it to production, because it's not real till it gets to production. We like to write our code, but our managers like to see it ship. Our business users like to see it happen. Our security folks like to make sure that it's all tight and secure when it gets deployed to the web. And one of the most important things is when we have changes to make, we like to make sure that those changes that work on my machine work on every machine. So we don't have any of those stickers floating on there saying, yeah, it works on my machine, I don't know what your problem is. So today's keynote is more about how do we take the code after we're done writing it and make sure that everything we're doing is preparing it to be in the cloud. So this isn't just about the cloud, it's also about getting ready for the cloud. So when we're done, it's nice to think about, yep, I'm done writing my code, I'm just going to press push and it's just going to go right up there. But let's walk through what happens when we do some of that too. First, when we write a lot of our code, do we always think about optimizing it? Do we think about tuning all the performance out of it? Probably not. Like I hear a lot about this all the time when I'm writing large applications. I remember being on one for a year and a half with over 100 developers. And about a month into the project, I was hearing, what's wrong with you? This website you're building is 20-something meg. It's going to take over a minute to load on regular Wi-Fi, and it's going to take even longer on mobile with slow Wi-Fi. You know, you're a terrible developer. What are you doing? Well, so we haven't optimized it yet. We got to work on some of that. And people get scared about that word optimization because what is it exactly you're going to do? Does it just mean you're going to bundle your code and minify it? There's actually a lot more that we can do. And I'll walk through the scenarios and kind of talk about the personas of our development efforts, figure out why we're trying to optimize that code and how we can actually do it. And then building our code. Building JavaScript used to be simple about 5-6 years ago. Hey, look, there's a script tag on the page, or 400 of them. Just stick your script tag on the page and let it run. Today, things have changed quite a bit with our build processes, where we no longer just stick a script tag on the page. Now, we've got processes that actually optimize our code, as I mentioned. We bundle it. We've got things like lazy loading of JavaScript to the browser, HTTP 2, which some servers have these days. So we've got a lot of things to think about how we can load our JavaScript the fastest. And we'll talk about how we build our JavaScript consistently. And then deploying it. There are several options in how we can deploy our code to the cloud. All of them are good. Maybe one works for you and another works for you. It really depends upon what you're trying to accomplish. And I'll talk about those different scenarios so you can decide which one might be best for you and understand the pros and cons of each of those. But first, let's start off talking about some JavaScript. We just wrote our app. Maybe you're writing an Angular, maybe you're writing a React, maybe it's Vue.js, maybe it's just plain old JavaScript. But when you're done writing your JavaScript, we have to think about how we're actually going to put this together. So looking at some of the new tools that are out there with JavaScript, they come with these CLIs, command line interfaces. And the reason they come with the command line interfaces is because it's not just putting a script tag anymore. Now there's so much more going on. They're trying to wrap up and make it easier for everybody to run, create, build, test, deploy their applications. So Angular has a CLI, so does React, and so does Vue.js, the three leading JavaScript libraries and frameworks. Let's take a look at how a normal flow might work. With Angular CLI, you say ng, that's the CLI name, create a new app, and you give it a name. Pretty easy. This will generate the app for you with all the files you need, and you can even set certain options like routing or prefixes. One of my favorite options is called the dry run. I like to call it practice. So the practice run lets you verify what's going to happen. Have you ever generated a new project, like Visual Studio, new file, new project? It's created like 40 files, and then afterwards you look at it and go, ooh, that's not exactly what I wanted. And then you got to go and you got to delete it, or you go, maybe I'll just refactor those 40 files. Well, what's nice about the dry run flag in a lot of these newer CLIs is they let you preview exactly what it's going to create without actually creating them. So you can take a look. It'll tell you in a report, this is what I'm going to create. And then you can say, okay, I like this, take that flag off, let's rerun it again. So when you're done, you just remove the flag and you're good. Now, you only do this once per project. So while a lot of the CLIs get this great name from, wow, they can scaffold and generate a whole new project for you, like file new project, that's only a one-time thing. Where they really, really come into play is when we start looking at how we're going to build our projects. They take away the heavy lifting for us. So let's talk about build personas. When we're building our code, there's really two target end audiences here. The first audience is me, the developer. When I'm writing my code, my persona is that I want to be able to write my code, build it, see it in the browser, make changes, build it, see it in the browser. Repeat this process, probably 500 times a day. Just compiling over and over again, looking at my code, editing it, seeing the results. I want to see it instantly. I don't want to wait a minute or 2 or 3 for it to build, because then I've got all this time that's in between, and get a cup of coffee, I get distracted on Twitter, who knows what happens. Look at cat videos. So the developer persona is all about building locally and getting that first fast development experience. What I don't care about is how big the files are. 20 meg, who cares? It's going from my laptop to my screen. It's not that long of a distance. I can load up 100 meg if I want to. So my persona in this case is fast builds. Then we look at the other persona, which is our end users. Our end users don't compile 1,000 times a day. They don't care about compiling. They just care that the fast, quick, responsive site is there for them. That time to first interactivity is super quick for our users. So for that, we run different flags. And the flags we run for those are ng build with a prod flag. And again, the Vue and the React CLIs also have similar kinds of flags. Now there's this other flag that came out with Angular recently called Build Optimizer. It's actually now baked in if you're using version 5. And I'll talk about this one more because it's really fascinating, some of the things we can do with JavaScript these days, which you may not be aware of. So the end goal here is to get that build as small as possible, as fast as possible, get that user really moving it. So we'll explore what these two different flag settings do. First of all, you might have different environments. When I'm building locally, I only want my development environment. When I'm building for production, I probably want to use my production environment settings. That's the first difference. Cache busting. When I'm building locally, I don't care. I'm going to turn off caching in my development browser so I can just see the latest changes. But do you really want to call all your end users every time you deploy a new application on the web and say, yeah, you 1 million people in the world, could everybody just stop for a minute, clear their cache in the browser and reload the site for me, please? We put an update out. So instead, we can use something called cache busting, which will put a unique file name on all of your files, and it automatically tells the browser, look, you haven't cached this before, load a new version of this out there. Absolutely ideal for production. Source maps. This is something I do want in development mode. I want to be able to debug my code. Unless you write error-free code. Anybody out there do that? A couple people? I saw a hand in the back. Thank you, sir. I'm going to hire you. Well, in production, I don't really want those source maps. Why? Because I don't debug my source code in production, not when I can avoid it at least. I can turn them on if I want to, but it's probably better not to do that because the source maps are big files, and again, we're kind of defeating the purpose of speed if we're sending more stuff to the client. Uglification. I love the words in JavaScript. It's the process of taking all your variable names and function names and shrinking them down to illegible things like X and Y and Z. Shrinking down the size of your files and your projects to make it smaller, getting rid of white space and comments. Makes it ugly. Bundling. Let's take all the files in your project. You might have 1,000 separate files and compile them into one. I hear a lot of times, oh my gosh, JavaScript, so many files. Well, in the end, everything gets compiled to one file and it goes to the browser. The browser doesn't care. It doesn't care that you've got a nice pretty folder structure on your machine. It just wants one file. And then code splitting. So code splitting is the process of allowing the user to go to one page of your site, get it really quickly, and then behind the scenes, you may not even know this, but behind the scenes, the place you're about to go to next is loading while you're waiting. So we don't load everything up front. Instead, we split out our code into very discrete units so we can load the first thing first, and the rest of it comes behind it, possibly in the background. This allows us to do things like lazy loading of our JavaScript, which allows us to even have a faster time to first interactivity with the browser. Now this one's unique to Angular. It's called ahead of time compilation, AOT. What this one does for us, when I'm running in development mode, I have to compile all my templates in JavaScript, because I'm doing all this data binding in the templates. I have to compile those. Well, two things happen there. First, I have to compile it, so that's a process, and that takes time. Second, it needs a compiler to do it. JavaScript comes with its compiler, and so does Angular. It has its own Angular compiler. So if we compile it every build, every single time, what we're really doing is we're sending the compiler to the browser and then telling the browser to run the compiler before the user gets to see it, which means the user has to wait for the compiler to travel to the browser and it has to wait for it to parse it. Well, why do we want the user to wait like that? In production mode, we'll compile it on the server one time, not even send the compiler to the browser, and just send it up to the client. So now, instead of making all 1 million users of your site wait for the JavaScript to process, you just make them wait during build time once, and then everybody benefits from the really quick response times. And then one of the more recent ones, and I think this is going to come real big in 2018, is a term called tree shaking. Have you ever written code, I know you have, where later on you decided that you didn't need it, and then you started removing it at some point, maybe not right away. And then later on comes to find out, maybe a day, maybe a week, maybe a year, maybe never, that you didn't remove all that code. It's still there. You've got references to DLLs, libraries, and things that you're like, you know what, we're not even using this thing. I often found out with .NET, by the way, when I'd be referring to some kind of third-party library, I'm not using it, and then the library would break compatibility someday in the future, and I'm trying to fix it. I'm like, wait a minute, we're not even using this thing, and it broke our act. So wouldn't it be nice to just have a tool that could get rid of all the dead code in your project? That's what tree shaking does. Tree shaking is called such because it's like taking a tree when you were a kid. I don't do this anymore. I should go do this. Go find a tree out today. Everybody's job is to find a tree and shake it today and see what coconuts fall to the ground. Just don't stand under it. The coconuts that fall to the ground are the dead code in your project. So the idea is it goes through and traverses your dependencies and says, hey, you're using that, you're using this, you're using that function over there. This function over here, there is no path through the code that's going to make this execute. So I'm going to remove that. And it figures out what it can get rid of. So tree shaking is a very powerful aspect that we want to do at production. And it really reduces the size of our builds. So overall, these CLIs, Angulars, React Views, they all make the process of creating production builds smaller and thus faster to get to the browser, and sometimes even faster in the browser. So there's some tools that we can use to analyze this. And once we build our project, there's flags you can turn on. Like I mentioned here, you can turn on source maps. That's the SM flag. So SM says, hey, turn your source maps on, and there's a tool called Source Map Explorer. Source Map Explorer will do exactly what it sounds like. It explores your source map and it says, hey, this is what you're using, and it shows you a visual diagram of everything in your project. So you can now look and see, okay, this is what I'm using, and it gives it in relative size. So you can determine what things are taking up the most space inside your project. There's another one called Webpack Bundle Analyzer. And Webpack's what a lot of the new JavaScript libraries use to do their builds. When you build the project, you can tell it to spit out the stats file. This stats JSON file has information that Webpack Bundle Analyzer can use to help you determine what kind of things you're using in your project. Very similar tools, they both take a different approach. One of them looks at Webpack's output, the other one takes a look at your source maps. Between the two of them, you can often find something that might be good to get rid of. And you can get these from these links up here. And I'll share the deck later today on the internet. Let's take a look at how this works. All right, so in this project, and I'll provide a link to the code here, everything I'm showing today, you can try on your own later on. I'll provide a GitHub link, repo, and a README file so you can walk through some of this. So in this project, it's an Angular application with a Node server. We can see our Node server down here. This could be .NET, could be Java, doesn't really matter. When I take this project and I want to build it, let's run through some of those commands here and see what happens. I'm going to pull up this terminal, do it right from VS Code. I'm going to say ng build. So right now it's going through some of those processes that I mentioned earlier. It's doing a development build. But in the development build, it's going to build out our files, not do cache busting. It's not going to do the tree shaking. It's not going to do a lot of those optimizations. But it did do quite a bit. So let's look at the file names here. We've got inline bundle. What's that? 5K. Who cares? It's 5K, right? It's very small. The inline bundle is basically the bootstrapper for your project. Every project's going to have something that kicks it all off. The next one is the main bundle. Think of the main bundle as, this is my main code. It's code I wrote. It's code you wrote. It's about 40K here. This is the one that we have the most control over, but it's also the one that's going to grow the most, right? As we start pulling in more stuff. So we should keep an eye on this one. Then there's a polyfills. Polyfills, 200K, that's a decent size. This one you have a little bit of control over. It depends upon which browsers you're targeting for your end users. By default, Angular and a lot of these libraries come with polyfills that help it work in all the major browsers, even back a couple of versions. If you don't need to support some of the older ones, you can remove some of the polyfills and make it smaller. Styles, that's our CSS. And then the last one, vendor bundle, 2.7 meg. That's a little bit bigger than the 40K I wrote, isn't it? So that's what we don't have control over. We don't have a lot of control over code you did not write. And that scares us sometimes. And we hear a lot of times, oh my gosh, why would I pull in this library? It's so big. So let's take a look at what we can do by simply just running a new flag, ng-build prod. And then we'll take a look at the file sizes before and after these two. Oh, you gotta love when you have different versions of things running in your project. We'll go up there, come back down. Somehow it thinks that I have different versions running. ng-build prod. Try it one more time. Nope, she's unhappy. I got a version mismatch. Well, let me just tell you what happens. Hey, it actually tried to spit out some of the files. It's kind of neat. So it actually did the job, but it didn't like the end result. So what happened here is we have 4 files instead of 5. If you remember, the first time I ran it, we had 5 files. The second time, we had 4. You might think, that's amazing. It got rid of the vendor bundle. That was the big one. I don't need vendor code anyway, right? Actually, sometimes we do, right? We might need our vendor friends to make really cool stuff for our libraries. What's actually happened here is our main file, which is now, well, it's only 86. It would have been bigger. Our main file actually becomes the combination of our vendor file, which was up here, and our main file up there. So the 2.7 meg and the 40K from our old code actually gets trimmed down to about 500K total. So we go from about 2.7 meg down to 500K. That's 80% reduction, simply by running a prod flag inside of the library. And then if we add this new flag, which came out just literally 3 days ago, this build optimizer for Angular, it does tree shaking, and it reduces that down to 350K total. So now we're going from almost 3 meg down to about 300K, almost a 90% reduction of our code simply by running flags on our CLI. I keep telling the teams, just add more flags. Eventually we'll get to negative sizes of files. It'd be kind of cool. So these files are pretty cool, and you know, it's neat because it does a lot of magic to us to reduce the size. But what happens when we have other problems? Let me give you an example of something that can happen to you. So in this project, let's say I've got this service, and in this service I'm using this library called RxJS. RxJS is a library which allows me to do asynchronous operations like HTTP. And with that, I might want to use a catch statement to catch my errors. I might want to map the results, what comes out of there. I may want to run all these operators, lines 7 and 8 up there. These are operators in RxJS. When I run these, those are using strings to point to a file to bring in that library. What happens if I end up using like 20 of these imports? I end up with all these statements for catch, and maybe I've got a finally, and maybe I've got a do, and I've got a bunch of things I'm pulling out of RxJS. Something I hear about a lot when I go talk to folks is, this gets really ugly, John. I'm not doing that. I'm going to do line 9 instead. I stick that line 9 in my project, everything will still work, and now I have one line of code. I don't have to manage every single operator I'm using. It's just a lot easier to deal with. And it still works. Hey, if it works on my machine, who cares, right? Guess what this is doing? oh, I'm going to pull in every operator RxJS has. And because it's a string and there's no symbol name there, guess what Angular can't figure out? Can't figure out which ones you're using or not. So instead of pulling in the 2 to 10 that you might be using, now you're pulling in maybe 100 of them. This will jump the project size from that 2.7 meg originally in the original build over to 4 meg. So you're having over a meg of files you're not even using. And the tree shaker, worst of all, can't figure out how to get rid of it. So while there's tools to automate some of the stuff to get rid of code, there's still things we have to be smart about. And that's making sure that if we're not getting a symbol like we are on line 4 or 5, for importing a library, like here on line 9, we have to make sure that we don't get the whole library, we just get the pieces that we need. So we still have to go in our code and really analyze that. And let's go out to that link that I had here. I'll show you an example of what this bundle tool can do. Here comes the browser. So this is a tool called Webpack Bundle Analyzer, and here's an example in an animated GIF of what it might look like on your machine. Notice the large rectangles. The larger the rectangle, the larger the file. The larger the file, the more you should be looking at this. So let's back out a little bit. You'll notice that he's looking through inside the animated GIF through the different things. What I look for in this is when I see a large file with a lot of tiny rectangles, that's when I'm like, am I really using all those things inside those rectangles? And you can kind of start clicking on them and exploring to see, is my project using these? But better than just telling if you're using them or not, it's also giving you a size comparison so you can kind of figure out, is this something that maybe is taking up more space than I need? I remember working at a place recently where we had written our own library to handle promises. I don't know why, but we did. There's like 20 of them out there in the web. Somebody wrote their own library to handle promises. And it worked, and everybody at the company loved it because it worked, and they had been using it for like a year. And then I showed them this tool, and I said, that's great, but you're not getting updates, you're not getting, the new stuff that comes in promises on the web. I said, that's okay, we're happy it works. I showed them the tool, and I showed them how large the file was that they created to write promises. And then I brought in the other promise library and how tiny it was. And they're like, oh, you mean it does the same thing? I'm like, yeah, and more, and it's smaller. Because you're getting the benefit of open source in this case, because maybe 100 people contributed to that library. Maybe Sally behind her desk was working on it while Joe reviewed it, and that's it. So it's a nice way to look at the code inside your project to figure out maybe how to make decisions upon your application. All right, so that was our demo there. But once we build our application, we've now got it small. We've got it tight. We've got it fast. How do we make this work everywhere? Some of you may never deploy to production. Does anybody here never deploy ever? Because I want to work with you. I really do. I've got a friend. His name's Ward Bell. He's one of the funniest men on the internet. If you don't follow him, you need to. Ward Bell's amazing. He's like, John, I just don't care. I never deploy. That's somebody else's job. I'm like, I want that job. Well, even if it's somebody else's job, you can help make it easier for somebody. I'm sure you've at least had this experience. Have you ever written code before? And you gave it to the person sitting next to you, and they said, you suck, it doesn't work on my machine. Yeah, you have. And then you're probably not, first inclination is like, you're not feeling empathy for them. You're like, too bad, you did something wrong. What'd you do? Well, wouldn't it be nice to not have to worry about this stuff anymore? So I worked at a place where we had Windows 7, we had Windows 8, we had Windows 10, we had Ubuntu, we had CentOS, we had Mac OS and multiple versions of it. And then in production, we ran Linux. It was like, what else can we possibly run? And every time we built, I never knew. It was like spinning the roulette wheel. What's going to come up? Come on, man, black, black. And it just didn't work. And it became really problematic. And beyond the operating systems, what happens if you're running a different version of .NET than they are, or of Node than they are, or of NPM, or of NuGet, or of Angular, as we just saw a moment ago? When you see different versions, what happens? Things can break. So the real crux of this is, how do you make your code work everywhere? So the answer to this, think about what we want to do. We want to take the code we have and reproduce our environment. Get our OS and our platform in place. Install our dependencies for our project. Build all of our assets for whatever platform we're using, .NET, Angular, React, etc. Build out our web server, and then copy it all to some kind of distribution folder, very likely on some other server. Even after you do all this, though, we have to make sure that our platform works everywhere. And we have very little control over what's in the cloud. We have lots of tools and portals and CLIs to play with it, but it's somebody else who's managing that. I can't go physically touch it. They may not let you in the data center. They won't let me there, that's for sure. So when you can't touch those things, how do you make sure that it works here, it works everywhere? So what we really want to do is we want to automate all this with confidence and consistency to make sure that what I do just works. This is where Docker comes into play. And some of you might be like me when I first heard about Docker for the first year or two. Oh gosh, somebody's going to wrap up my project inside of this thing called a container. And the container means I can't get to it. This worried me for a long time. And I started doing retrospection on myself to think, why does this bother me? Why does Docker bother me? It's going to solve all these problems. And everybody in the world is using it these days. Not everybody, but I love when people say that. Everybody's doing this. So everyone's looking at Docker. What are they looking at it for? Why is it successful? Well, it's helping us solve the problem we just talked about building everywhere. But I have my own problem. As a developer, I don't like things or trust things that don't allow me to have control over my code. So let's think about what that means. The things I really like to do, and I'll bet you do too, is you like to be able to debug your code. You want to know that if you run it in that container, you can still debug that exact code and walk through it, and then examine variables and change things. You want to make sure you can access the file system inside the container. Well, I built a container, but like once it's in there, can I poke a hole in it and like just peer through and see what's going on? Okay. And what about checking the logs? Like when the server is running, I like to look at the logs and monitor it. Can I do that as well, all locally on my machine? Because before I ever think about going to the cloud, I want to make sure I can do all these things. And on top of that, I want to make sure that what runs locally runs the same as it does in someone else's machine or in a staging or production with different environment variables. So I have to build my application with that in mind. So, okay, let's take a step back on the cloud and say, before we go there, let's look at how Docker may or may not solve this for us. Docker has this thing called a Docker file. Very creative names, right? And the Docker file is a self-contained script. It's our recipe for all the things I would have done locally anyway. It's those things that say, go ahead and get my version of Node, get npm, install my scripts, build my project, and stick it in this folder, and adapt to my different environments for me. So it's going to do all that for me, and it might look something like this. In this case, we can automate it because we've just scripted out exactly what we're going to do. And this Docker file is really nothing new. We've all done it before. It's simply what we do locally. It's just saying, hey, you know what? The guy or girl next to you who's trying to run your app, when they have a problem, you're telling them, what version of Node do I have? Well, I've got 6.11. Where's your source code? In this folder. Are you doing npm install? Ooh, I forgot to do that. Okay, now build the project. Did you run with these flags? Did you expose it on the port 3001? Did you run node index? We're just scripting out an order and sequence the things we need to do. And once we script it out and write it out, not only can the person next to you run it, but everybody can run this. So we've now automated our build process. So we create this Docker file, then what? Then we build and run it. And after we build and run it locally, what we want to do is we want to debug it. Because then I want to test to make sure that I can still access all the code that I have. So let's go take a look at a demo running Docker. So in my application over here, scroll down a little bit, there's this cool Docker extension that you can get for VS Code over here. Definitely check it out. It'll let you look at certain images and containers. An image is basically what you build, it's your recipe, and a container is a running instance of that image. Over here on the right, you can see I've got an Angular version of my project. Once I've built my project out, all I have to do is say, okay, look here, show the logs of that. It's running right now. And if I pull this up, you can see the logs, and it's telling you it's listening on a debugger port from 9229. It's using my development environment, and the API is running on port 3001. I can even click on it here, and it will open the project up there, and I have no data at this point. What else can we do? Well, we can right-click on this, and we can attach the shell. This allows me to look inside of my Docker container, and I can start looking at the files that happen to be in there. And there's all the bundled files that we built from the Angular project. So we're seeing what Docker puts inside of the project for us. All right, let's close those down. What if we want to build it? Well, here's my Docker file. This one's a little bit longer because I'm doing a little bit more, something called a multi-stage. First, I'm building my Angular project, then I'm building my Node server, and then in the end, I'm just saying copy the things out of those two, put them on this new image, expose the port, and run it with Node. And if I want to run it from Visual Studio Code, I just open up the command palette at the top, and I type in compose up, Docker compose up, and I can choose a debug version or my production version. And I'll show you the differences. We'll let the debug version run while it's going. And if I open up the compose file, you'll see down here, let's make that smaller. Make that smaller, there we go. You'll see in the compose debug file, I've got Node environment development set up in line 8. And I'm also exposing port 9229, that's the debugging port for Node, so I can attach the debugger. And then finally in line 12, I don't just run Node, I run Node with the inspection flag to tell Node, allow debug symbols to be accessed. Let's look at the regular Docker compose. Almost identical, except I removed the debugging settings, and I changed the development flag to production. So it's just a flipping of the switch. When I run locally, I run with the debug. When I run anywhere in other environments, I run it with the production version. Now you saw that my Docker container ran, and it's over here. Let's go check out the logs again. Let's bring this up. We can click on port 3001, and it's over here, and there's my application again. So what if we want to add some code? Let's go up here, and we'll refresh. I think I have to log in. I've got some security here. Yep, I'm using Twitter to log in. Everybody should use Twitter, right? We'll put it in here, and we'll put in John as my name. My saying is hello, and I added it. Oh, we don't have a database, do we? How do we get the database? Well, this is one of those things that when you're running in the cloud, you don't think about, because it just exists, right? So when we have local code, one of the things we want to do is make sure we've got our database set up. So here's our database file. And normally we write databases locally so we can run locally on a machine, and then we move to the cloud. So you're like, oh my gosh, never thought about this, right? When I'm running locally, it's right here, my Mongo database SQL server's here. How do I get that into the cloud? So right now I'm pointing at a cloud connection string on Azure. Let's change that to point to a local database right here. And once I do that, we can rebuild our Docker Compose. We'll have it go ahead and build that up again. In the meantime, we can go check out how we can create a cloud database server. So over in our extensions again, there's an extension called Cosmos DB. Now this will let you talk to Cosmos DB, but it also lets you talk to local databases. So notice down here I've got attached Mongo servers. Here is my data in my heroes database, and there's my data. There's a hero named Starlord and one called Gamora, and they're all hanging out over here locally. Up in my cloud, I've got this database, but I don't have that heroes collection. So what I can do is I can create a database up here, and I can call this My Heroes, and I can call the collection in it called Heroes, and then it should appear over here on the left inside that pane once it's done doing so. And then once I do that, I can actually take the data locally and push it into the cloud as well, right from the extension. So here's my Heroes up here. I've got a couple databases. There's my Heroes database, there's the hero collection, and there's one record right there. And then I can also do My Heroes DB. So now that we've rebuilt the Docker container that'll look locally, let's look at our application again. And come back through. And let's make sure we got the network open. Yep, and it's pending as it's trying to find our local instance. So it's trying to go get our data, but how do we get that data from here and then into the cloud? So if we right-click on the collection itself, this is locally, you see this little button at the top? That's called a scrapbook for Mongo. So we can click on that, and we can type in and get IntelliSense right inside of VS Code for our collection. We can say, go find all of our heroes. And then I can right-click here and say, execute the command, or I can use a keyboard shortcut, and then we'll see the data that happens to be in our database instance that we've got. So don't save that one. We'll come back over. And we can switch database context by saying, OK, come over here. Now connect our database, open a scrapbook, type in a new command, like we can do find again. Oops, heroes find. Like that. Run our command. And there's our data over on the left-hand side. So we can run these commands by simply just saying connect to the database you want, run the command in the context, look at the results. And we don't just look at data like finding, we can insert data, we can update it, etc. So how would I get this data into the cloud? One easy way, it's probably not great for mass migrations, is to copy the results out of your local. So I just did a copy, and I'll close down these windows. And now I can go up to a cloud database like this My Heroes. And there's my heroes, there's nothing in there. I'm going to come into this one, and I want to connect to this one. I'm going to open up a scrapbook, and I can say db.heroes.find first, just make sure there's nothing there. And then I can do db.heroes.insert_many, and I can paste in that data, and I can insert it. Notice it said it inserted the data, and I run it again, and there's my data in the cloud. So we simply just took the local data and copied it up to a cloud database server. And now we can switch our connection string back over to production so we can check this out. So let's go back over here. And we'll close down our results. We've got a lot of results, don't we? All right, so now that we have that all set up, inside of our Mongo server, we're pointing at our local database. Maybe we want to go back to the cloud. And in this case, we have to know where are we looking in the cloud. When we run a production, notice my production Cosmos settings are all using environment variables in lines 5 through 8. I'm going to set those up at production time. Maybe I don't own those keys. Maybe an admin does. But at development time, I might set some of those keys up. And I'm not going to show you my real keys, but I'll show you some fake ones. So here is what we would set up locally. In local development, and I would git ignore this file so nobody gets it in GitHub. Here's my keys so I can run locally and hit the server. And then I don't have to set up all those environment variables every time I run locally. And that gets set in a project using this flag right here on line 5. I say, hey, go get the environment file called development or production based upon whether I'm running in development or production. So at runtime, it's going to figure out which one to go get based upon an external configuration, this process node environment. And we can set that in Azure. So once we have all of these, we can then go build our app in production. And we can build it up like this. So let's go build our production app. And while it's building, we'll take a look at the debugging settings that we can do. So over in debugging inside of VS Code, they have this cool option called Docker attached to node. How do you get to this? Very simple. If I delete this out, I'll show you where you get these from. If you click on Add Configuration, you'll see, if it doesn't disappear on me, Docker attached to node. And then it adds in there effectively what I just had with a different name. So it adds in the ability to attach to Docker running with Node. And it knows I'm using Node in my project because it sees that it's a Node project with package.json and all that. So it's doing a little smart detection to figure out how can I attach to your project, where are your source files located. And then I can just click on this button when the container is running to attach to the local container. So when I'm in my browser and I'm looking at my data and I click on things, I can then walk through the code inside of Docker. All right, so we just built up our production Docker container. Let's go look at it. And there's our Angular one, and I've got a Vue version of this project too. The Angular one right here isn't working, so then we can look at things like Docker commands. We can go into Docker, and we can say, hey, let's run this Docker command separately. We can also use the CLI, so we can see the error message that it comes up with. There's my Docker compose. We can also go into command lines and run Docker as well. So there's various ways we can build up our Docker containers. And when they don't work, we just debug them. We right-click on them, we look at the logs, or we can attach the shell and look inside the files inside of our images. One of the coolest things, though, is check out this. Let's say I've got this image and I want to deploy it. I can right-click on that image and I can push right from here. And that'll push it up into the cloud in Docker Hub or into Azure or wherever else you want to go. And then from there, you can deploy it to a website that you might have. So once I've deployed one, it goes up into this Azure registry. And this Azure registry contains a few images of mine. One of them is this Angular Cosmos DB. I can click on that, and I can right-click and say deploy it to an Azure App Service. Now, once I do this, it's going to prompt me for like what's your subscription, what's your resource group, I can select a bunch of these in here, say put it in this group. It's then going to ask me for a plan. I'll pick a plan that I already have, give it a new app, we'll call it Papa Live 360. And then it will go ahead and build out a web server using the container and the image that I have. So we're now seeing how we can build Docker locally. We've got these debug options. We've got options to use production and development environments. We'll give that time to build. Let's look at some of the commands that we actually ran through VS Code. First, we ran this compose command. You can run that from the command line, or you can use the tools inside of VS Code to run it for you, which is what I prefer, just easier. I don't have to remember all the flags. And then we actually tagged our image. Tagging our image is giving it a name, so we both can identify it, and we can version it, and it tells us where it's going to get pushed to. In this case, my registry at Azure's container registry. And then finally, we push it up to, in this case, Azure. Once we do all of that, and we push it up there, we can deploy it to one or more websites just by clicking a button. And we never had to go to the Azure portal to do anything, which is very cool. But we still have a problem. What if I'm out to lunch? What if you're out to lunch? Still only works on your machine because you're the only one who can get to it. So how do you take these images that we're building and make sure anybody can build them? So this is where CICD comes into place. And the workflow we want here, CICD, is we want to take our code and we simply just want to push it to GitHub. I want to make changes. I want to push it to GitHub. And then I want GitHub to take that code and let the CICD servers I have know that the code has changed. So I might be using Jenkins or Visual Studio Team Services or any other CI/CD program, and have that know, okay, look inside in GitHub, get that code, go build it. And the build process is going to build out our container running that Docker Compose. And then when it's done, it will put it in the container registry and then deploy it to a web app for me. What this does is effectively everything I did manually, it's now going to do locally by pushing. We just write our code, push to GitHub, and then we back away from the keyboard. And then GitHub takes it, hands it off to CICD. CICD does its unit test, its Docker build, pushes it to Azure, and Azure launches it in the cloud. Every time we have some kind of a change, we can have push. You might be wondering, well, what if I don't want my developers to push and immediately deploy to the cloud? Well, there might be different situations. You might want to have a development server where everything you're constantly pushing and merging with pull requests gets deployed to the cloud. But then you've got a production server where you're like, I don't really want to take production down in case somebody makes a mistake. So what you could do is you have different release processes inside of CI/CD. And there's some good sessions this week where you can talk more about that. I think Damian Brady is doing one of those this week from the VSTS team. So you can learn how to do different environments that you can deploy to. All that's possible. For right here, though, we're just talking about how do we get it into the cloud. So let's take a look at some CI/CD processes. When I take a look at my GitHub server for this code, I'll go up into Azure Samples. Let's hope I have some internet access here. And the URL for this, I'll zoom in, is GitHub Azure Samples, Angular Cosmos DB. If you like Vue or React, there's a Vue or React version. Just change the name from Angular to Vue or React, and you'll see that. And then we'll get rid of that. When I make a change, we want to make sure it's getting pushed up. And I'm on the develop branch, because I'm not pushing to production, I'm pulling to a development server. And we can see in here all the changes that have happened in my commits. So let's go back down to my code, and what we could do is we can make a change, like we already made one here to Mongo, and let's get out of there. We're using our Mongo database to the cloud, at least I hope we are. Oop, I deleted the connection string, that's not good. Yep, so we'll do that. So I've got that connection string. Let's go into our application, and I've got a title here for the app, like Angular Cosmos to Azure. You can say, hi, Live 360, like that. Go into our GitHub changes, put a new title in, and I'm going to push. So now we do this, VS Code's telling me in the bottom left when you're done pushing. The numbers have disappeared. If I come back up here, it says there's a new pull request. And we can see we've got 12 seconds ago, we had a commit. So now let's flip over to our CI/CD server. And I'm running it in Visual Studio. We're just going to watch this process happen. You don't have to do this. It's just nice to see what's going on, because I don't know about you, but I don't like magic. So I've got this thing called a build. If I could highlight and click it. And here's my Docker build. Before I click on it, notice it says it's in progress. That's great. Well, let's see what it's doing. We click into it, we can click on edit, and we can see all the steps that our build process is working on. So here's our first step. Go get our code out of GitHub. Pretty straightforward. Second step, run Docker compose. It's going to run the same thing I ran locally, but run it up here. Now, I could also then run unit tests and end-to-end tests and other things as well. And then finally, since this is just a development server, I'm pushing it straight to the Azure Container Registry. If I wanted to have a development and production staging servers, I could have a release instead, and the releases are what you create up here. It's the same process with more with approvals. So how does it know GitHub has changed? There's this thing called a trigger, and you turn that trigger on. Effectively, that tells VSTS to go look in GitHub to see when the code changes, and then it goes and gets it. So let's back out to the build for a minute, and we'll see what's actually happening. We can click on this number 201 for the build, and we're going to watch paint dry. Just kidding. We're going to watch the build happen there. So it's been running for about a minute and a half. It's going through our scripts. It's doing, looks like an NPM install right now for some of the code. And it's going to follow all the steps inside that Docker file that we built. And then when it's done, it's going to take it and launch it onto an Azure website. I have this website called secureheroes.com. And it's up here. This is in Azure with a custom domain. And yes, there's a brother site called Insecure Heroes, because some heroes are insecure. And on this site, we have some slow internet going on here. Now it's unavailable. Oh, I had a bad build before because I checked in that connection string. On that site, it's going to have the application. So once this one's done, it's going to redeploy our container up to that site, push it to the Azure Container Registry, and then launch it. Let me show you what an Azure Container Registry looks like. So if we go back into our application, I've got this thing called an Azure Container Registry. It's effectively NuGet or NPM for containers. It's a place to store all the containers that you want to run in the cloud. And when you click on this, there's really only two menu items that are really worth looking at. One of them is called repositories. And the repositories will show you a list of all the repositories, the containers that you've pushed into the cloud. And from there, you can see what's actually in there. And it's the same view, if you don't like the portal, that you get from right here. Notice my container registry has two. It's got this Angular Cosmos DB, and it's got this Vue Cosmos DB inside the cloud. And if the internet comes back, we would see them on this page too. Here's another win for doing inside of VS Code. It's just there. So once it's in that container registry, then Azure knows, okay, I've got a new version, I'm going to deploy it right from here. So if we go back up, we can see this one failed over there. It can't get to the Azure Container Registry. Okay, so we've got an internet problem. But once it gets up there, you can go there. If you check out secureheroes.com later, I will redeploy it once I get access, and then you can check out how it gets to the cloud. So what do we really do with this? We built and run our code locally, and we can also set the debugging flags. You can still debug without Docker, but you can debug it with it too. And people ask me a lot, like, do you run Docker all the time? No, I don't. What I do, and the way I like to roll, and what I recommend for you all, is to run the way you normally do. Like, I write my code first, I get things working. I do make sure that all of my environment variables are configurable. Like, the things that I want to change between my machine and your machine in production, I can change. And I use those through environment flags, because we can set those inside of Azure. And then once I'm ready to start moving and building in a development server or something up in the cloud, that's when I start pulling in Docker. And it's very simple to add in by adding the Docker files. We'll take a quick look at that. And then when I use something like VSTS, I also happen to like Jenkins a lot, and Travis for open source projects, 3 different CI tools. All those work great for building and deploying your apps, and then launching it in the cloud using something like App Service for Azure. And you can run it on Linux, or you can run it on Windows. It's whatever's in your container. So if we go back to our debugging over here, one of the things I wanted to show to you was this other extension called Azure App Service. You may wonder, when you run in the cloud, how do you set all those environment flags? Well, one thing you can do, and there's our new website that got launched, one thing you can do is look inside of the app. I'll look at this one. There's an application settings node. And in the application settings, we've got all these environment variables. I think it's having problems getting to the internet again. But inside of here, you'd see all those flags that we set inside the code. Let me show you what would come up. So back in, oh, there they are, good. Back over in our production file, notice we had Cosmos DB account, Cosmos DB database name, the key, and the port. All of these settings are right there. You can see partial security key right here. Not only can you see them, you can add them. Add a new setting. Let's add a new setting called Papa. And they can say hello, because everybody needs one of those in their application. And then you can change keys right from here as well. You can say, you know what, that's not the name of the database, let me edit that, and I can change the values right here. You can delete keys. Notice the node environment is set to production as well. So you can change your keys right from here. Again, no need to go to the portal or the CLI. You can do everything right from these extensions, which is just pretty cool inside the application. All right, and to kind of summarize all this, I'm a developer at heart, and I like writing code. That's what I want to do. So what I really want is I want to make sure that I can spend the most time doing the things I love, which is writing code. And to do that, I have to minimize the things that I don't enjoy as much, which is deploying, quite frankly. I like to see my code run in production, but I don't like watching it get up there and do all that. And you probably don't either, right? Like figuring out how to get there. Maybe you do. But what's nice about it is, why have all the ceremony of what we used to do in the past? Now we can have these really cool tools that make just work everywhere. We can use Docker to script out what's happening, give it a good recipe. We can then push it up into the cloud using these automated tools. We can use VS Code so we never have to leave our editor. As a developer, that makes me feel comfortable. It makes me feel safe. It makes me productive and efficient and fast at doing everything right inside the environment that I know I can use. Docker just makes it work everywhere, which makes everybody at your company and all your users happy. In the end, we have a couple links here to kind of help you out. I want you to try all this if you could, and send feedback to us. You can see my link here up on Twitter. I'll be happy to help you out. The first link will show you some documentation on how to do some of what I showed today. The second link will get you right access to the code up in GitHub. You can open up issues right there. You can run the code. You can read the README file and follow the steps to reproduce it for yourself. Notice I'm pointing right to the develop branch. The master branch is different. The develop branch is for the changes I keep making. If you're into Angular, I've got this cool extension called Angular Essentials, which you can check out. It's free for Visual Studio Code. It gives you lots of cool stuff to light up Angular inside of VS Code for you. And then all the extensions that I showed today come from this one link, extensions for Node for Azure. And they're not just for Node, like the Docker extensions there, the app service, the Cosmos DB, using Azure CLI, even logging into Azure right from VS Code. All that comes out of this little link, this VSC-node. You click on that, it loads inside of Visual Studio Code, and then you can use all the features that you saw me use today. And if you don't have Azure, you can get a free trial right up here and have fun, build as many things as you want to. With all that, though, I'd be happy to answer any questions outside after all this, and I want to thank you all for coming. And again, if you have any questions, please feel free to find me on the internet and have fun deploying your code.